right, so this is how I usually like to start after exam 1. So you guys decided to study on your own, right? I gave you some pointers of maybe using the review and stuff like that, right? Now, some of you guys did what I asked, and you got the grade that you got, and that is on you. Good, bad, or ugly is still on you. So, question is, did you like your grade? Right? For some of you guys, the answer is heck yes. For some of you guys, the answer is heck no. So, I typically like to have you guys answer these 4 questions. So somewhere in your notebook, open up where you can get to it quickly, meaning maybe it should be the last page of your notebook, right? The back page of your notebook. And I want you to just answer these 4 questions. This is nothing to be handed in. This is for you. Has nothing to do with me whatsoever. Okay? So question number 1 is, how much time did you spend studying for the exam? You don't have to be specific. You can just say 3 weeks, 2 days, 3 hours. How much time did you spend studying for the exam? So this is going on the last page of your notebook, answering these 4 questions. Now, I do believe that these 4 questions you should ask yourself after every single assessment that you have in every single class. So if it's a project, ask after a project. If it's a paper that you wrote, answer these 4 questions. Okay? This is how we grow. I ask these questions all the time when whatever I'm doing. Right? No matter if it's yard work, no matter if it's something with woodwork, I always ask myself these questions. So even in my private life, I still ask these questions. So how much time did I dedicate to studying for the exam? Question 2, what resources did you use? Meaning, did you only use a review? Did you use the best cheat sheet ever? Did you use your condensed notes? Did you only use MLM for those extra problems? Did you use ChatGPT to give you more problems to work on? Answer that question. For question 3 is this. When you brought your exam up to me or from home before you hit the submit button, what grade did you expect to get? Did you expect that you were going to get a C, but you turned out getting an A? Did you expect to get an A, but you turned out getting a B? Right? We have different expectations when we hand it in, and then the grade comes back, right? So either we get a pat on the back or a pat on the face, right? So what did you expect to get for that exam? And question 4, now that you know what your grade is, how would you change the time that you spent, question 1, and the resources that you're going to use, question 2, for exam 2? How are you going to change those 2 answers for exam 2? So again, for the ones that are coming in late, I'm asking the students in class to turn to the back page of their notebook where they can easily access the answers for these 4 questions. To answer these 4 questions for themselves, I'm not collecting them, so you can be very honest, right? You can answer however you guys want to, because this is really you looking yourself in the mirror and saying, what am I doing? Okay? So if you took the exam in class, your exams are up here, so feel free to come and pick it up. It should be in alphabetic order from A to Z. Go. Should be in alphabetic order. It was a little blocked, so don't blame you. Should be in alphabetical order. Anybody else? Nobody else. Okie doke. For the ones that took my advice of doing the review, did I lead you incorrectly? No? Did anybody not do the review and think that their way is going to be better? Now, even that being said, there's still some of us that, even with the review, is not helping you. I understand that. So the question is, what resources do you need in order for you to do better? Now, I said day 1 that some of my students have, actually some of them are as well, have watched the videos before they come to class. So their notes were already done when they came to class. So they got exposed to everything already. Because here's the thing. The reason why I have my Canvas course set up the way it is because of this. My notebook, when it was totally filled, when I copied the notes, when I did a really good job copying the notes, I hardly heard a single thing the professor said. I was in your seat once. Many, 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 many years ago. Longer than you've been born. Okay? So when I was sitting in your seats, my notes were either filled and I didn't hear a single thing the professor said, or my notes were empty and I heard everything the professor said. I couldn't do both things at once. I had a hard time listening and writing something down at the same time. This is the reason why I lay it out the way I lay it out, because now you have a choice. If you're good at that, great. But if you're anything like me, not great. So I wish that my professors had videos already done so I can do the notes ahead of time, so that when I get to class, I knew exactly what I didn't understand and what I did understand. And I'm ready to ask the questions that I need to ask based on what I don't understand. And with the notes being done ahead of time, because some of you guys will do that, but you guys will do the notes as in just copying the PDF or playing the video without any sound. If you play the video without any sound, you learn nothing. If you only copy the PDF, you will learn, well, I'm sorry, I shouldn't say you will learn nothing. You will learn some things, but not the whole lesson. Same thing with copying the PDF. You'll understand some things, but you're not going to get the gist of everything. Every single one of you guys are different. Different type of students, different type of learners. You got to do you. You got to find your way. Right? You might only need to do 5 problems and you're like, I'm good. I'm comfortable. I'm game ready. I can do any problems like that. You might need to do 20 problems for that to happen. You might need to do 30 problems for that to happen. Every single one of you guys are different. Now, some of you guys already had asked questions in class, and I hope that you guys realize that I don't mind explaining them. Right? So let me ask you guys this. What do you guys need from me to have you guys get better grades? I don't need to listen. I don't need to hear from the people that get 100% or 96 or 92. So just so you guys understand this as well. There's no shame in asking the students that got the 100, got the 96, got the 92, got the 84, got the 88s, to ask them, how did you study? And try that. Because chances are, it might work for you. Chances are, it might not work for you. Right? Because when I was in your seats, I had 3 jobs. None of them paid well, but 3 jobs, right? I was a work study at the print shop. I was a volleyball official, and I was also a travel volleyball coach, all at the same time. And I played awesome. So my days were busy all the time. Go, 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 go. And I was trying to find ways of organizing myself. So I'm looking it up, and I see this, I see that. I see the agenda, I see this. I tried them all. None of them helped me. None of them helped me. So just because it works for someone doesn't necessarily mean it works for you. However, if you take the parts that did work for you from each individual, you'll find your way as well. Okay? So any questions for me at this point in time about anything? Or any feedback that you might have that might help me help you get to where you need to get to? Nothing? So lab work 4A is kind of scary to me because so anybody that handed one in got 100%, but I still made comments. So if you haven't read the comments, please read the comments. Because I believe one of the lab works that we graded, and I really only looked at number 1 because that's why I see really quick, and then I made the comment. And here's the scary part. in one of the lab works, did we not grade something about f of, I think it was f of 2, is that right? Is that one of the lab works? In fact, let's see if I can pull it up or not. Was it lab work 1? Nope. It was a, wait a minute. Oh, maybe it wasn't you guys. Maybe it was college algebra. I thought it was you guys. Dang it. It wasn't you guys. So, I mean, I thought it was you guys for sure. Am I misspeaking? Yeah, it was you guys. It had to be. But I can't remember which one it was. Huh? Okay. It was f of negative 2. And what did I write on the right side, on the what we know? So my question is, did you write, since we, and I sent it to you on the answer key, right? Did I send that to you? No, I'm saying I thought we did it before. Now I'm very confused. Where did I do it? I can't remember now. Yeah, because that's what I'm looking at. I'm like looking at lab work 1 answer key, and it's not there. Oh, that's college algebra anyway. Oh, no, that's you guys. Because someone actually said that f of x is a quadratic equation. And f of x is not a quadratic equation. And I'm not sure where you got that from, right? And most of the comments that I wrote down was the very common, the common one that I put down was make sure that none of the information from the problem goes into what we know. So if you didn't do that, then you didn't see a comment. Okay. So, but I thought that we did that before, where I was trying to say, hey, that's what we're trying to plug in. And maybe I'm thinking about lab work 1 where we're plugging a point in, right? So, and I've been teaching this for so long, maybe semesters are starting to intertwine with each other. So, but if it's a problem that's already been done, feel free to just copy that what we know, right? And again, what is from the problem should not be in the what we know. As someone said before, it should be a guide, right? A guide, not specific to the problem, all right? So any other questions for me at this point in time? Nothing. So we're ready to move on to exam 2. Okie dokie. So exponents. Let's talk about exponents. So we're talking about powers, right? So on the left, I'm going to put examples. And then on the right, I'm going to write the rules. Okay? So first example. If I said x squared times x to the third, what is that equal to? What is it?
X to the fifth power. Don't you add the exponent?
X to the fifth. Now, if we did not know that, here's what I'm going to show. X squared means x times x. X to the third means x times x times x. And if you look at that, how many x's are there? There is 5 of them, right? That's why it's x to the fifth. So the question is, what did you do with the 2 and the 3 to get 5? And you would say, you add them together. So if I have a to the n times a to the m, that's going to equal to a to the n plus m. So when we're multiplying, so the a just means the same base, different or same powers. Okay? So the base has to be the same. The powers can be different or the same, but we add those powers. Okay? What if I did x to the third divided by x squared?
X to the first power. So you subtract the exponent.
Awesome. Since in multiplying we would add them, that means in division we would subtract them. So if you notice right here, right, if I was to spread it out, I want you guys to notice something. If I said x divided by x, what would that equal to? What's x divided by x? Is it x? So are you saying that 2 divided by 2 would be 2? Ooh. Put it in your calculator. Do 3 divided by 3. 4 divided by 4. 5 divided by 5. What do you get? 1. So these will all come out to be 1s. So that's the reason why this is equal to x to the first power. So what did we do with 3 and 2 to get 1? Now, I don't like this rule. I hate this rule. I'm going to tell you how I would go with this rule. I have 3 x's on top. I have 2 x's on the bottom. 2 of them cancel out. That's where the 1 comes in. I have 1 left on top. Everybody see that? Okay? 3 on top, 2 on the bottom, 2 cancels out, right? It's always the smallest amount that cancels out. And then the question is what's left and where is it, okay? So if I was to turn this around, what is this going to equal to? X raised to what power? Is it 1? It'd be negative 1. Question is, where does that go? We'll talk about that later as well. But I want you guys to keep this in mind right now. Okay, so I'm just going to bubble this, and we'll bring it back up later. This is the reason why I don't like this rule, because that confuses you. Because you guys don't know where it goes. Ah, so x to the negative 1 power is not the same as negative x. So this is not equal to that. Okay? So please be careful. And these things you can try on your calculator. So you can do, let's say, 9 raised to the negative 1 power. And when you hit equal, it won't equal to negative 9. Okay? So again, you will see this. We'll talk about this in just a second. But you will see it. Okay? Let's get to the next example. What if I said x squared raised to the third power? So let me ask you guys this. The third power, what is that attached to? The parentheses. So it's touching the parentheses. Okay. If I have something raised to the third power, what does that mean?
Multiplying it 3 times.
So you got to write this 3 times. Okay. And what's x squared again? What does x squared mean again? X times x, right? So that means here I have x times x written 3 times. Okay. How many x's are there? There's 6 of them. So what did I do with the 2 and 3 to get 6? Multiply. So a to the n, raised to the m is equal to a to the n times m. Are we okay there? Okay? And the reason why I'm putting these examples up there is so that in case you forget what the rules are, you can do an example like this, making sure the powers are different, and then actually going through it. Okay? So that you guys can go, oh, that's what the rule is. Okay, let me ask you this. What if I did this? X times y squared raised to the third power. What would that give me? So before you say anything, what is this power of 3 attached to? You're going to tell me what? The parentheses. Awesome. And then the third power is telling me what? Bless you. To write this 3 times. Is that right? So if that's the case, what is this going to give me? X to the y to the,
X, Y, never mind.
go ahead, x to the third, y to the
6.
excellent, right? So notice what happens, right? What happens is this. If I had a times b raised to the mth power, then the a will get that power, and the b will also get that power. So I'm basically distributing the power through. But with the y, since I'm raising a 2 to a 3 power, that means I would multiply those 2 powers, just like with the previous rule. Okay? And it works with division as well. Well, you know what? No, I'm just going to put the rule there. Okay, so multiplying or dividing is the same rule. All right, here's my next question. What if I said x to the 0 power? Ooh. Again, pull your calculator. I want you to do 9 raised to the 0 power. You get 1. So anything raised to the 0 power is going to equal to 1. So anything raised to the 0 power is going to equal to 1. So, guys, just so you guys know, the letters X and Y, because the whole thing is that you guys say math got confusing when we start using letters. Fair to say. However, I want you guys to understand something. Is that those letters, those variables that we call them, are just numbers. So if I want to try the x to the 0, I can try a number. 2 to the 0, 3 to the 0. The only reason why we use a variable is because we don't know what the value of that variable is yet. So to try to figure out what x to the 0 would be, we can try a number. Right? So you can always try that number. So beforehand, someone asked about if something being raised to the negative 1 power. What would that be? So let's go ahead and take a number. Let's say 8 and raise to the negative 1 power. Actually, let's do this. Let's use a different number. Let's use 4 raised to the negative 1 power. Throw that in your calculator. Tell me what you get. 4 raised to the negative 1 power. And then change it back to a fraction, please. What do you get? 1 over 4. You'll see that this is going to be 1/4. Holy cow. Which means that anything raised to the negative 1 power, or actually negative nth power, that's going to be now 1 over a to the positive nth power. So let me put this in perspective for you. So similarly, if I did this, what do you think that's going to equal to? If the power is on the denominator and was to the negative power, what would that give me? For your calculator, do this. Do 1 over 4 to the negative 1 power. Tell me what that gives you. It gives you 4. So in other words, if it was a raised to the negative n, it's going to be a raised to the nth power. Now, let me put this in perspective for you. This is like a baby. Okay? So here's, ready for this? So let's say a mom takes the baby going shopping, right? Goes grocery shopping. When she comes home, what does she have to do with the groceries? Put them away. So she's holding the baby, but she's got to put groceries away. So what does she do? Doesn't she, when she put her down, like in a playpen or something, right? Leave her for that. Dad's not there. Dad's at work, right? Because chances are she's not going to hold the baby and put the groceries away, right? So she's going to put the baby into the playpen or something and then try to put the groceries away. What happens when the baby is on top, now goes to the playpen, down? What will happen with the baby? Wouldn't the baby start crying? Right? Because the baby was really happy in mom's arms. Now that it's away from mom's arms, starts crying. Right? It's not the playpen. Right? Meaning it went from positive attitude to a negative attitude. Went from a positive attitude to a negative attitude. Right? If the baby starts crying in the playpen, what does mom do right away? What does bad moms do right away? When they pick them right back up? Happy again. Everybody see that? Okay? So, let's say, for example, baby wakes up in the morning. You put her in the playpen. She starts playing with her toys in the playpen. She's pretty happy, isn't she? Right? She's pretty happy. Now, grandparents come in to the house. Grandpa goes and picks up the kid and goes, "Oh, my grandkid," right? What does the baby do right away? She's happy in her playpen. She gets picked up. What happens? Wah! Starts crying, right? Because she doesn't realize who just picked her up. She's like, I was really happy in my playpen. Someone's pulling me away from the playpen. So she starts crying. Happy. Negative attitude. So what does grandpa do right away? Because he always gets scared. Puts her right back down. And then after a couple minutes, she's like, pick me up, right? So if you think about that, that's what is typically happening. If it has a negative attitude, you will move it, right? Wherever there's a negative attitude, you will move it to the opposite side, okay? Any questions there? No questions. We understood everything that Chan has talked about so far.
When the exponent is negative, you flip its side and it turns positive.
Correct.
Okay, thank you.
Mm-hmm. So if it's negative on the bottom, it will go on top, it becomes positive. If it's negative on the bottom, you move it to the top, it becomes positive. Okay? All right, so let's start with a very simple example. So let's say I say a to the fifth, b to the negative 1, and c to the negative 8. What would that equal to? What would that equal to? Anybody? Nobody? Anybody want to take a chance? Just throw it out there. Go for it. No. So, and this is a very common thing, right? So remember that when I wrote A in here, or I should bring it up here first. So when I write A, that means the A and so A raised to the N and A raised to the M, meaning that the base all has to be the same in order for them to combine the powers, okay? And that's the reason why over here I will use A and B, because they're two different variables or two different numbers being raised to the number, to a different number, right? So we can't push A, B, and C together because they are separate. They're three different numbers. Anybody else want to take a chance?
So you keep them the same.
Say that again.
So do you keep them the same way?
You wouldn't condense it the same way, no, because they're three different things. So A is A, B is B, C is C. So they can't combine as one thing.
No, what I mean is like a to the power of fifth, b to the power of -1, and c to the power of -8.
Uh-huh.
Right?
They are separate, yes. Now, here's what the direction is going to ask you to do. It's going to ask you to rewrite this in positive powers or positive exponents. So how do I rewrite this in positive exponents?
So you put them over 1.
Okay, so this is going to be a fraction. Awesome. Like it.
So it's going to be a to the power of fifth, and then you put the negative number in the bottom.
So here's what I like to do. I'll say, does A like being on top? Because we can write anything as a fraction, right? By putting it over 1. So all of these numbers here are all in the top. Does everybody understand that? Are we okay there? Okay? So with that being said, I would say, okay, does A like being on top? And the answer is yes, because it has a positive exponent, positive attitude. Does B like being on top? No? Okay, so we move them to the bottom. Does C like being on top? No. So therefore, we move C to the bottom. Does that make sense? Yes? Questions?
I have a quick question.
Go for it.
So once it's a negative power, so when do you since it was a negative power, right? So we keep it as a positive power since we put it over 1.
So again, what happens to the baby when she's crying? You would put her down.
Okay, gotcha.
If she's crying when she's down, you would pick her up. Right? So she doesn't like being on top, so let's put her on the bottom. She doesn't like being on top, so let's let her be on the bottom. She loves being on top, so let her be on top. Any other questions? You mean why did I not put the first power? Do we ever write anything to the first power? Like when you write x, do you write x to the first power? Because it's understood, right? So the power of 1 is understood. That's why we don't actually put the power on there. Any other power would need to be on there. Okay. Then they all go move. It'd be 1. So the question was, what if all of these were negative, right? So what would be on top, and that would be a 1. Okay. Any other questions? Okay, let me ask you guys this then. What's negative 9 raised to the 0 power? Try again. Why is it negative 1?
Because it's up to a 0 power. Anything that's equal to a 0 power is equals 1.
So why is this negative 1?
Because there's a negative, it's a negative number.
So again, I ask you, this 0 right here, what is it attached to? It's attached to the 9. Excellent. Okay? So therefore, I still have that negative, but 9 raised to the 0 is 1, so that's why this is equal to negative 1. However, what is that equal to? Huh? That's equal to 1 because what is the 0 power attached to? To the parentheses. So it doesn't even matter what's inside the parentheses. Once there's a parentheses, anything inside the parentheses being raised to 1, raised to 0 is 1. Okay? We're okay there. Because the power of 0 is attached to the 9 and only the 9. So this is equal to 1, but the negative is still there. Correct, because the power of 0 is attached to the parentheses. So let's see how you guys do with this. What is that equal to? 2x to the 0 plus 4. Huh? Which equals what? Do you guys at home agree with 6? No questions. We're good with 6. Ask your questions. Well, 2 times 1 plus 4. So again, this 0 is attached only to the x. Bless you, I think. Gesundheit. 4 to the 0 minus 8z to the 0. And we're going to get ¿Por qué? Does that make sense? We're okay there? So no questions. Oh, you want harder problems? No problem. Anybody have an answer for this yet? What's the first question we should ask ourselves? What's the first question we should ask ourselves? Okay, what is the power of -3 touching? And you're going to tell me what? Okay. So what do I do with that power of -3? So if I was to write some steps, I would tell you that step 1, I should distribute. What does that mean? That means every single thing in the parentheses should get the power of -3. Okay? So here we go. Ready? Mm-mm. Does that make sense? Every single thing. So 4 is just a number. Remember, I said that these are just numbers, right? So 4 is just a number, A is just a number, B is just a number, C is just a number. They're just numbers. So in other words, I have 4 to the -3rd. I'm not going to do anything with that. I have A raised to what power? Do I multiply the powers when I raise the power to a power? B to the, oops, and C to the, awesome. What should I do now? How do I put them together? Do I like negative exponents? No. So what should I do now? Say that again? How do I turn it into a positive? Oh, so you want me to just do this? Oh. Like that? Say that again. Make it a fraction. Let's find a word for this. Right? Because really, I could put this over 1, right? Because that would be a fraction. Right? So what am I doing with this and this and this? Huh? How do I, so just put them on the bottom? How about we use the word move? Is that fair? So does the 4 like being on top? Does the A like being on top? Does B like being on top? Does C like being on top? And then step 3. Simplify. Why do I say simplify? Is there anything to simplify here? The 4 to the third. Now, guys, notice something here. I did not do anything with this right here, did I? Because if you type that in your calculator, what do you get? If you type 4 raised to the negative third power, you're going to get 1 over 64. Do you have any idea where to put that? So that's the reason why I wait until simplifying to do anything with it. Right? I want to make it a positive power first, then I would do 4 to the third, which means 4 times 4 times 4, which is going to end up being 64. So those are the 3 steps I would tell you to do. There are many ways of doing this. I find that when I follow these 3 steps, I get everything taken care of. Okay? Because here's the thing. If I really wanted to, from here, I could have just, because of that negative 3 power, I could have just flipped it. Put it on the denominator. Well, the problem is that then when I distribute the power, I'm going to get negative powers, and I'm going to have to move them again. All right? So for me, I'd rather just distribute the power, move them, then simplify. Any questions? So let's try Oyo. Good luck. I'm going to use the little boy's room, and I'll be back. So go at it. Get somewhere? No. What's the first step? Yep. So do that. Remember, 5 is separate too. So 5 gets that power. Just like over here, the 4 got the power as well. Right? Five is a different number than A. So 5 gets the power too. Don't do anything with that number yet until it becomes a positive power. Because right now, what are you going to do with 1 over 125? And then on the denominator, you're going to get 1 over 1,000. Are you going to put that in there? I wouldn't, because it would look really, really intimidating. Okay. So you did the first step. What's step 2? Move. Awesome. That's not true. Absolutely. Everything gets it. Do you like that? Does that look intimidating? Given the fact that you guys don't like fractions, now you got to see a fraction over a fraction? You're able to, but that doesn't give you jack squat. That's not true. That is not true. That's not true. So guys, pause. So over here, when I distributed this negative 3 power, right? Which of the numbers inside the parentheses got that negative 3 power? Every single one of them. Meaning the 4 got it, the A got it, the B got it, the C got it. Is that right? So why is it that when we come here, we decide that 5 doesn't get it? Should the 5 get it? Yeah. The 5 should get the power too. Does the 10 get it? Yes. Because if everybody up top is the only one that gets it, that's not fair, right? So first of all, the negative 3 power is attached to the parentheses. Is this not what I did? Isn't this what I did up top in the previous problem? I did exactly that, didn't I? Okay. That's distributing. Okay. So now here's my question. What did I do with this? Hey. Because it starts at noon.
It starts at 12?
You're in college algebra, right?
Yes, I'm
yeah.
super early.
Hey, better than me late. So, when 4 was being raised to the negative 3 power, did I do anything with it? I didn't. So should I do anything with the 5 to the negative 3 power? I even said to you guys are going to be tempted to type it in your calculator, right? And some of us did. Right? Because if you type 5 to the negative 3 in your calculator, you know what it comes out to? 1 over 125. Do you really want to put down 1 over 125 right here? No. That means not just the fact that you already hate fractions. You're like, let me put more fractions in there. Right? So for me, I'm just going to do, okay, this is 5 to the negative third power. What does the a on top give me? A raised to what power? B raised to what power? Awesome. 10 raised to the negative third power. A raised to the B raised to the. Okay. So this is why I call it distributing. Right? When I said step 1, distribute. This is what I mean by distribute. All right? Now, some of you guys need this step. Really need this step. Some of you guys won't. The more of these problems that you do, the less you're going to need this. But for now, I tell you to include both of these steps. Did you have a question? Okay. So this is what I called distribute, or the step 1. Any question on distribute right now? We're okay with this? No big deal. Okay. Any questions at home? We're okay? We're good? Okay. Now we move, right? So we ask ourselves the question. Does a 5 like me on top? So we move. Now notice that I'm just going to go straight through here. And then I'll go through here. Okay? Does A like me on top? Does B like me on top? And notice I'm separating these according to like variables. Okay? Does 10 like me on the bottom? It does? Looks like a negative power to me, right? So it doesn't like me on the bottom. Does A like me on the bottom? Does a B like me on the bottom? Ask your questions. Where's our confusions? Where's our speed bumps? What's holding us back? Yes? Absolutely. And B. But does this make sense? Does the moving part make sense? Right? Remember what we said. Like the baby. If we put her in the playpen, she starts crying, what do? We pick him up. Doesn't like being there. So we pick her up. Doesn't like being there. So we pick her up. Doesn't like being there. So we pick her up. Right? So it's not about the negative power being on the bottom and the positive power being on top. It's nothing to do with that. It is we move if they're negative. Right? So let's say, for example, that there was simultaneously a 1033, an intermediate algebra class, going on upstairs. Okay? Different professor, obviously, because that can't be in two places at once. And you hear about lab work, and you're like, screw this guy. I don't like this guy. I don't want to be in this class. Am I going to force you to be in this class? No. You want to go upstairs? Go upstairs. You go up there, you're like, whoo, I'm much happier because there's no lab work. Okay. Right? Same idea. Okay. Any other questions? Jaden, if you're speaking, I can't hear you. And since your camera's off, I definitely can't even see you, so it doesn't really matter. But clearly you're talking. All right, so from here, we simplify. So let's deal with the A's and B's first. How many A's are on top? Try again. Because that's the first rule, isn't it? Same base, different powers. What do we do with the powers when we're multiplying? We add the powers. So 9 plus 9 is 18. Okay, so tell me more about not understanding the moving.
So when it comes to the negative power, I just don't understand how it goes to the top now. That's the only issue I'm having with.
So again, so you understand why they would move to the bottom.
Yeah.
Is the same exact reason why they would move to the top.
Please elaborate.
Because of the negative attitude. So this 10 right here doesn't like being on the bottom, right? So if she doesn't like being on the bottom, she should move to the top. The same exact idea of, since she doesn't like being on the top, let's let her move to the bottom.
But like, how do you decide that it doesn't want to be on the bottom or at the top? So that's the confusing part.
They don't, but, wait a minute, repeat that question.
Like, how do you know which one that doesn't want to be on top or the bottom?
What's in common with all these so far?
Negative.
Negative power, negative attitude. That's why they all. So that's why these all 5 of these move.
Okay.
Right? This one here did not move. This one stayed.
Okay, so you're saying that let's say negative like 5 to the power of the third, negative to the power of the third. So that goes since it was on top. Okay, since it was on top, so you bring it to the bottom. Is that how you move it? Okay, cool.
Because if you notice all of these, right? This moved to the bottom. This one moved to the top. This one moved to the top. This moved to the top. And this moved to the bottom.
Okay, so you just rotate it. Got it.
So anytime there's a negative attitude, you move them.
Thank you.
All right? So with a B, so here, if the bases are the same, we add the powers. So that's why 9 plus 9 would give you 18. Okay? Now here, you would typically subtract the powers, but I don't like that rule. Okay? So here's what I'm going to say. I want you to picture 18 B's on top, 9 B's on the bottom. Okay? So let me write this out for you. Let me write this out for you. So this is 18 B's on top and 9 B's on the bottom. Everybody okay? All right, so think of this as like the worst game in the world. All right? Meaning, it's the war of the North and the South, and one soldier eliminates each other. So 18 B's on top, 9 B's on the bottom. 9 of them cancel each other out. How many B's are left, and where are they? Wouldn't it be 9b's on top? All right? So, again, when we look at this, the top is always going to win this, right? And it's going to be left over with 9 of them. So that is going to be b to the 18th. I mean, sorry, b to the 9th, because there's going to be 9b's left on top. Does that make sense? We're okay with that. We're clear. We're good. Questions? So this is only talking about this part. We haven't done the number part yet. Just so you guys know, 5 to the third power does not mean it's equal to 15. It's not 5 plus 5 plus 5. It's 5 times 5 times 5. Okay? Which is 125. Now, you guys are welcome to say this is 1,000 over 125 and figure out what that equals to. As a math person, I should say this. If you don't understand what I'm about to explain to you, you're welcome to do this. You're going to get the same answer. The reason why I don't like to do this, I'll show you why, is this. What's 10 to the third power mean? Is that what that means? And 5 to the third is this. Agreed? Okay. What goes in 5 and 10? Well, 5 goes into 5 once, goes into 10 twice. Is that right? Goes into 5 once, goes into 10 twice. Is that right? Goes to 5 once, goes into 10 twice. Is that right? What's 2 times 2 times 2? What's 1 times 1 times 1? So you're saying that this is going to be my answer. Now, if you did 1,000 divided by 125, you're still going to get 8. You're still going to get 8. Questions? Nothing? None whatsoever. So 10 to the third is 10 times 10 times 10. 5 to the third is 5 times 5 times 5. This is equal to 2. This is equal to 2. This is equal to 2. And which gets 8. Okay. Any other questions? Nothing? All right. There's a name for 2. What is this name? The number that goes in front of the variable is called what? It's called a coefficient. What is the 3 called? We just talked about it. We also call it the power, right? And what do you call the x? What did I call it when I was talking about it? I wrote a and a, meaning they're the same base. It is a variable, but because that variable has a power, so it's called the base. Okay? So coefficient, base, exponent. So in order to add or subtract polynomials, you need like terms. What does it mean, like terms? What does that even mean, like terms? What does the word like terms mean? And so the base has to be the same, the exponent or the power has to be the same. If those two are the same, then you have like terms. So what you would do is keep the like terms and add or subtract the coefficient. Are we okay there? So no problems. All right. So which of these are like terms? Six, 4y squared and 6y squared. Awesome. The x squared and x squared. Awesome. How about the xy and xy? Yeah. Oops. So you're saying that these two are like terms. These two are like terms. And these two are like terms. Now, why did I include the sign in front of the coefficient? Why did I include the sign in front of the coefficient? Well, the sign in front of the coefficient is the value of that number. So the plus 4y squared means that the 4 is positive. Make sense? The negative xy means that it's a negative 1. Make sense? So if I was to add these together, what would I have? Now, if you have something like this, guys, it wouldn't be a bad idea for you guys to go ahead and actually stack them. And add them that way. Because what would I have now? What would my answer be? How many x squares do I have? Because what did I say here? Keep the like terms, add or subtract the coefficient. I guess I should put s there. So what's my like term in minus x squared minus x squared? Huh? Notice I said keep the like terms. Negative what? Anybody else? Negative 2 what? Just negative 2x? To the 4th. Okay. Let me ask you guys this. So, the way I look at adding, subtracting polynomials is this. Every base and its power is a fruit. Okay? Every base and its power is a fruit. So I see x squared, those are the same fruit. Does that make sense? Are we okay there? xy, different fruit. Not the same fruit as this. Right? So let's say x squared, it's a banana. Is that okay? xy, strawberries. Y squared, again, not strawberry because it's not xy. Not banana because it's not an x squared. It's a y squared. So let's call them kiwis. I don't know why. Well, let's call them kiwis. I guess I should have just did that in a different color. Does that make sense so far? Okay? If you said to the 4th, is this a banana? So if I took two bananas away, took a banana away, does it go some other fruit? It's still bananas, isn't it? You don't sit there going, yeah, I lost 2 peaches. But they stole bananas from you. How did it become peach? Does that make sense? So that's the reason why this should be squared. Is that fair? Because again, it has to be the same fruit, right? The end result has to be. Okay, how about this? I got 7 strawberries, took away a strawberry. What do I have? Don't have 6 strawberries left? Wouldn't it be weird if you were at Walmart and you got a basket of strawberries and you took one out and all of a sudden you're like, what the heck? Why is this a basket of blueberries? And you put the strawberry back and go, oh, there's strawberries again. It doesn't work that way, does it? Right? All right. I got 4 kumquats. Kiwis. 4 kiwis and 6 kiwis. What do I got? 10 what? 10 kiwis, right? So, here's my question. Looking at this result, does these words now make sense? Keeping the like term, adding or subtracting the coefficient. X squared is a like term. We keep the x squared. We add the numbers in front. -1 gives me -2. xy, that's my like term. I keep it. 7 minus 1 gives me 6. Y squared, that's my like term. 4 plus 6 equals 10. Is that fair? We're okay? Questions? No questions. So again, adding, subtracting polynomials is like adding, subtracting fruit. Right? That's the reason why I couldn't add x squared and xy's. Right? They're 2 different things in the basket. Right? Okay. I guess I should have called this a Oyo. All right, go for it. Tell me what that equals to. What do we get? Did anybody else get this? What's the first thing we should be doing here? Distributing the negative. So this negative needs to be distributed through, correct? So I should have this minus 7y squared plus 8y minus 9. And if I add them together, oopsies, I should get this. Does that make sense? Any questions there? Nothing? Nothing at all? All right, so I'm going to warn you guys about something really quick. Starting Wednesday. So everything you learned so far is basically going to be set for the rest of your math career. So adding, subtracting polynomials, you're going to need to know. Those exponent rules, you're going to have to remember for the rest of your math career. So everything you learned today, you better know it inside out. And here's the other part. For exam 1, if you decided to memorize and dump, you're going to be in trouble. Exam 1 isn't as bad, but if you decide to do that for exam 2 and on, you're going to be in a lot of trouble. So if you decide to memorize and dump, the rest of your math career will hurt a lot, because that means you'll have to relearn everything over and over again. So I'm going to tell you right now, do not memorize and dump. If you have, relearn and keep it. Okay? That's number 1. Number 2, starting on Wednesday, everything that we're learning to do forwards, we have to also know how to go backwards with. Meaning, which is something that you've done all your life, right? We learn how to tie our shoes and untie our shoes. We learn how to get dressed and also undress. Understood? There's not much that we do every day that we didn't learn in both directions. Right? Besides brushing teeth, I guess. Because I guess we don't clean teeth and get teeth dirty. That'd be hard to, well, we kind of do, but not knowingly, like not physically going, let's make it dirty now, right? So, but everything else we do, right? Ladies, well, some of you guys, put makeup on, take makeup off. You gotta know both. Man, that lady that keeps on just throwing more makeup on every single day, poor girl, right? It'd be bad. Right? So everything starting from Wednesday, everything that we learn how to go forward with, I want you guys to look at the answer and going, how could I go back to the answer? I mean, the question. So how did I go from the question to the answer, and can I go from the answer to the question? All right? So that'll be Wednesday. So get enough rest, get enough sleep, be ready to learn on Wednesday, because that's what's going to happen. So ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys all on Wednesday. Later.